afternoon, everyone. Today I want to do a quick tutorial on using the Planetarium simulation software that we will be using for several of the labs here. So this program is called Stellarium, and it's a free web-based program that simulates the night sky. All right, so this week you're going to have, or start working on at least, your first lab. So if you navigate to our course site, here under content, we're going to be doing this first lab, Stellarium scavenger hunt, and it will be due next Thursday, February 4th. So I've placed this lab in the chapter 1 content, as it is more of an introductory exercise. A note on this document with the directions: if you downloaded this document prior to today, when I'm filming this is Tuesday, January 26th, you will need to come back and download this version. I had originally attached the wrong version of this. It was for my version for last semester, and some of the questions are not relevant to this time period because, of course, different things are visible in the night sky in the winter and spring than they are in the late summer, right? So make sure that you download this copy that says Spring 2021 version. Okay, this will be the link where you come to submit your document once you have completed it. You can download this as a document file and push enable editing, and you can type your answers as you work through this directly on the document, right? And then just save that document and re-upload it through this same link, right? This will allow you to upload a local file to turn in as your assignment. Make sure that you save it as a .docx or a PDF file. If you are using a Mac, Mac tends to use a .pages file as a default for saving files. I am on a Windows machine. I cannot open a .pages file, so make sure that it's either a docx or a PDF. Okay. So in this document, I have attached a link to the website we will be using. You can control click to access it from inside Word. And so this is what you're going to see when you go to the website. This gives a view of the night sky as it appears tonight at 1800 hours, right? 1800 hours and 10 minutes, which is around 6 p.m. So if you click on this little time box, you can adjust the time, right? So for this exercise, you want to set it to about 2100 hours, right? If it's 5 or 10 minutes off, that is fine. It won't make that much difference. I like to turn this left menu off so I get a good, nice screen, wide screen. Down here at the lower left-hand corner, this is where you set your location. Now mine is already set to Bowling Green because I use this program a lot. But if you click this location box, you can either click to use auto location, so it will go by your GPS location, and set wherever you are currently at, or you can mark a location using a map, right? Again, similarly, you can search whatever town you're in if you're in Bowling Green, Kentucky. Right. Okay. But that will give you your night sky as it will appear tonight at 2100 hours. You set it to 2100 hours, which is around 9 p.m. So when you first pull up the program, it will orient you to the north. You'll be facing your northern horizon. And of course, your eastern horizon will be over here, south, west. Navigation in this program, if you're using a device with a mouse, you can click and drag to switch your view. And you can also zoom in, right? So using a mouse wheel, you can zoom in. Right? And you can select an object, which will bring up a dialog box with information about that object. And this is where you will get a lot of the information that you will need to answer the questions in the document, right? So, for instance, this is Mars. Mars is at a magnitude of 0.35 tonight, which magnitude in astronomy is the relative brightness, so how bright an object appears to you. This is a reverse logarithmic scale. Reverse meaning that a magnitude of 2 is dimmer than a magnitude of 1. Right? So the lower the number, the brighter the object. It's also a logarithmic scale, meaning that an object with a magnitude of 1 is 10 times brighter than an object with a magnitude of 2. Okay. All right. So down at the bottom of the screen, you will see some more options. There's a constellations option that allows you to turn on constellation outlines. All right. We will talk more about constellation in chapter 2. Right. One thing I want to note, if you look to the north here, you might see some familiar patterns. For instance, right here at Ursa Major, notice that part of this constellation here looks an awful lot like what we call the Big Dipper, right? That's because it is the Big Dipper, right? But the Big Dipper itself is not actually a constellation. It is what we call an asterism. An asterism is a group of stars that are commonly recognized, but are not an official constellation, right? And if you look over here, Ursa Minor, that's the Little Dipper, what we call in modern times the Little Dipper. But this actually means Big Bear and Little Bear, right? And if you're saying, that doesn't look like a bear, well, this next button, the constellations art. If you want to know how they got a bear out of that, or over here for Leo, a lion, this will kind of show you some artwork to show you what the ancient astronomers were envisioning when they named the constellations as they did. All right, atmosphere. You can turn on or off. Right now it is on. If you turn the atmosphere off, it will show you what the night sky would appear like if Earth had no atmosphere. Right? So Earth's atmosphere scatters light. So light from stars, light from street lights, light from cities, gets scattered in our atmosphere, and it makes our night sky appear brighter. If you leave the atmosphere on, it will show you about how bright you can expect your night sky to appear at specific times. Right? You'll notice that the moon is out tonight as well. Right? And moonlight causes the sky to be brighter, of course, right? Because the moon is very bright. Notice that it has a magnitude of -12. Negative numbers, magnitudes can be negative numbers, right? So the lower the number, the brighter the object. Let's see what's next. Landscape, you can turn your landscape on and off, right? This is your horizon. You can turn it off to see stars that are below the horizon. I would suggest leaving it on when you're working on labs. That way you can only see things that are above the horizon. And then these two options, these next two, are coordinate systems. And we will talk more about coordinate systems, I believe, in chapter 2. But this first one is what is called the azimuthal grid, right? And this shows the grid lines for the out-as system that we will talk about, right? So in the out-as system, you are looking at the horizon. This is your 0 point. Right? As you go up in the sky, then you go up in degrees until you reach the point overhead. The point directly over your head, straight up, is going to be 90 degrees. Right? This is also what is called the zenith. Right? So the point, if you look straight up, directly over your head, is the zenith. Right? And then the azimuthal part are the vertical lines here, right? And it defines your direction, right? Basically the direction of the object. So I believe east starts the 0 point, and south, I believe, is 90 degrees. And so forth until you get all the way around back to 360 degrees, right? So these are all angular coordinate systems, right? Because the Earth is the sphere and the night sky, as it appears to us, is spherical. The next coordinate system is the equatorial coordinate system, or the equatorial grid lines are what appear on here. So if we go back toward the north, and zoom out a little bit, right? Kind of the central point of the equatorial system is this point here, right? And so this point aligns with our north celestial pole, right? So the point about which the stars and all the objects in the eye, or the stars in the sky, seem to rotate about, right? This next option is for deep sky objects, right? And so these are things like galaxies, star clusters, things that are of particular interest to astronomers and amateur astronomers. These are often the prettiest things to look at. Hold on, I'm struggling with my mouse wheel. Sorry. Technical difficulties with my mouse wheel. All right. But if we zoom in here, this is the Andromeda Galaxy. This is one of our nearest galactic neighbors, right? And here it's called the Andromeda Nebula, but it's actually a galaxy, right? It's called the Andromeda Nebula sometimes because originally the scientists who discovered it thought it was a nebula, which is a cloud of gas within our own galaxy. But this is actually an outside galaxy, one of our closest neighbors. And this galaxy is 2.5 million light years from Earth, right? So that means it took the light from this galaxy 2.5 million years to reach us, which is pretty cool. So that means when you look at these objects in the sky, you are literally looking back in time, right? It also has two little satellite galaxies around it, M110 and M32. All right. So that's kind of a brief rundown of how to use this program. So you will work through this document and answer the questions. Yeah. This number 5 is usually the one that students have the most trouble with. So you're instructed to turn on the equatorial grid lines and orient the view so that you are facing the northern horizon, right? So let's look at that. All right, okay. So I've got my equatorial grid lines on, right? And I'm gonna face the northern horizon, right? So right here's facing north. So I want to click the time button and I want to advance the time using the minute hand. And I just want to click and hold it so I can see the motion of the stars, right? So first of all, notice that stars seem to rise in the east and then they're setting over here in the west. But also notice, let's advance a little more here, get back to dark time, right? Also notice that the sky seems to move around a specific point here, right? So this question wants you to look for the point that the sky appears to move around and locate the star or give the name of the star that's at that location, right? Another thing to notice is that notice while some stars are rising, coming above the horizon, moving across the sky, and then setting here in the west, there are these certain stars here in this area that never go below the horizon, right? These are going to be what are called circumpolar stars. And we will actually talk about those in, I believe, chapter 2. And then you're going to do some stuff with circumpolar stars and the night sky in lab number 2. But don't worry about that yet. So that's a brief rundown of how to use this program. And that's all I have for you guys for this video. So I will see you guys later.